Okay, we are live. Hello, everyone. First off, apologies for starting 3 minutes behind schedule. Thank you for joining this broadcast. We have Victor on the line. Victor is an embedded systems engineer, and he's going to be walking us through today's session of C programming for Arduino. So feel free to ask your questions as they arise, and we will answer the questions. I also have in the studio with me John. John is a longtime friend of mine, and while he's currently a full stack engineer, he also has a background in embedded systems engineering. So we will leave Victor to start the session. So, Victor, feel free to share your screen. And John and I will be in the back flashing your questions on the screen and answering them. So, Victor, over to you.
Okay. Cool. Let me share my screen. All right. So, can you see my screen, please? Okay. Can you see my screen, please? All right. I believe everybody can see my screen. Um,
Yes, we see your
okay.
screen, Victor.
All right. So let me just go all the way here, right, and try to zoom this guy out. All right. Now let me do this. Sorry. All right. So actually, the Arduino code really is more of a C++, right, than it is more of C in a sense, right? Because the people that designed it, right, designed it, in a way to make it really simple to learn, right? And yeah, it has a lot of C++ features as well. And yeah, and I'll be, walking us through um, a project, right, that I've worked on. I've once worked on before, right? In fact, it was a project that pretty much brought uh, um the entire Invent One thing that I did to life. It's been a while I worked on a project, right? Yeah, so I committed to Git about 5 years ago, if you can see. Um, and then I completed pretty much everything, right? This was like the version one, right? That, and then including the Gerber files, right? Including the Gerber files, or the is it this? Let's check this one. I think this guy, yeah, including like how you can pretty much just wash it. If you want to create your own PCB out of this, right? A couple of folks have actually done something with this, repo and stuff. So, the idea actually, right, is that the board pretty much uses the Atmega 328 chip, right? It has two of it, and then it has the ESP266, right? And so the goal of this board is to be able to control devices right from the web. That is, I can send in something like this link. I can send in this link, HTTP. This will be the IP of your, that your ESP266 got assigned based on the network, and then you tell it that okay, it should set pin 2 as a state 1, meaning that you want it to set pin 2 of the Arduino board to high or low, right? Low as in it's going to turn off the pin, and 1 means it's going to, like, send high to the pin, high in terms of 5 volts and low in terms of 0 volts, pretty much. So I also did couple of examples where I did some Python scripting that you can just, for example, this
Victor,
one.
can you zoom in on the fonts, please? On the
Oh, okay.
browser fonts. Yeah, it's pretty
Oh, okay.
tiny. Yeah, I think that's better.
Okay, okay. So, yeah. So I also did this some Python scripting, right? That allows you to, it just does like a for loop, right? Through there was a motor connected to a motor was connected to one of the pins of the Atmega 328 chip, which is pretty much an Arduino, right? A motor was connected to it, and a Python script pretty much was written, and then the Python script just kept using this request library, right? And just kept sending, right, data into it pretty much. Just can, this is the payload, right? The payload. And then if you notice, this guy sets the signal based on the for loop, right? So it just keeps going from 0, 1, 2, 3, 4, 5. And as it happens, right, if you see this in real life, right, what happens is that the motor connected to the pin, right, just keeps rolling faster. You just keep rolling gradually, gradually, gradually. It's pretty interesting to look at actually, and there are a couple of other stuff, right? So I think okay, there's this other one is a DHT remote monitoring. I think it's just a desktop app, right? It's a desktop app that that shows you the readings of a DHT. That is the humidity sensor, right? DHT11 sensor, right? So yeah, so this is the codes that run on it. The first one is for the first Mega. The second one is for the second Mega, and then the third one is the one that sits on that is written into the ESP266 chipset, right? And pretty much what it does is pretty much what it does, right, is that it connects to a particular Wi-Fi, right? With this is the chosen SSID and password I wanted to connect to, right? It connects it and then it sets up a server within itself. The server then runs on port 80, right? And then it now begins to listen for clients to basically send like restful content to it. Pretty much send like a post, send like a get, because it's now running an HTTP server on it, right? On itself. So pretty much it's then looking for different things, and then by the time you send it, you send like a post, a get, it then sends you a response, right? A response, if everything goes well, right? It sends like a 200 UK response, pretty much, right? So yeah. So how does it move data, right? How does it move data that it received from the web, right? That is from the posts that you send to it, right? How does it send it to the other chipset? It basically uses serial to do that, right? It uses serial to send data back into those chipsets, because those chipsets are the workers. They are the guys that that does the real logic movement of, okay, setting the pins low, setting the pins high, and stuff like that, right? But what the ESP just does is just gets data
So,
off from
sorry,
there, right?
Victor.
Yeah.
Sorry to interrupt here. Can you zoom in so that at least
Okay.
24 lines show up at a time?
At the
Then that way
time.
people can read your
It's
screen.
okay.
24. Yeah, 24 lines. Yeah, so zoom in again. Yeah, yeah, that's better.
Oh,
Okay.
this is better, right?
Yeah.
Oh, okay, cool. All right. So yeah, so what we'll just yeah, so I was explaining that this is the code that basically sits on top of the ESP266 on the diagram, right? The diagram that I showed before. And then what this one does is it basically connects to a particular SSID and password, and then it sets up a server in itself, right? This is where it connects to the SSID and password, and it sets up a server within itself, right? On this port. This is where it set up the server here, right? And then yeah, so what it now then does is that it listens for restful request, right? It listens for post, get, and all the likes, normal restful stuff. And then once you fire a restful, like a restful API or is a restful request to maybe a post or a get to its IP, right? Once you fire a RESTful request to its IP, right, it will send the data that you sent to it to the two microcontrollers, to one of the microcontrollers, right? We using serial, right? Because if you notice, if we come back to the design, right? If we come back to this design, right, what we'll see is that the ESP is connected to one of the microcontrollers, right, via URLT. So when you look at it here is the ESP-TX, right, is connected to this ESP-TX, right, and then the ESP-RX. Where's the ESP-RX? Yes, ESP-RX is connected to ESP-RX, right? The reason for this transistor here is for the fast switching, right? So that it can quickly get the response quickly, right? Because there's a pull-up resistor, right, that allows it to quickly does this UART switching of high and low, right? It just helps it, right? You can also connect it straightforward, right? But most of the time you're going to lose data. But the reason for the pull-up resistor on the transistor switch, right, helps to basically allow it to get response accordingly, right, so that it's not too fast and it's not too slow, right? So yeah, so this ESP, right, is connected to this, right, via UART, and then this is also connected to this via UART. Pretty much the normal TTL that we all know, transistor logic, just does TX to RX and RX to TX, right? They basically just um, combine like that, right? So yeah, and right here is where we have the power management thing, right? That pretty much supplies power to the entire board, right? And it needs to have a particular amount of current so that it can, it can carry three of them at the same time. I remember vividly that it was using LM317, right? Because it's one of those regulators that that give out like high currents that you can use for this this kind of exercise, right? And then we now have an LCD connected to it. So the cool thing about this LCD is that you can pretty much just send something right via you can pretty much send like okay, so this is an example here, right, where to write to an LCD, right, you pretty much send something like you know you want it to display Joseph, right? And before you know it, you pretty much send this thing via maybe a RESTful API, and before you know it, it pretty much just displays Joseph on it displays it on the LCD. And why does it do that? Because it sends the data via UART to this guy, and this guy connects to this guy. So this one is just like the middleman between two of them. It's a very easy, tricky thing to do. It's pretty like a very basic, simple thing to do, right? So this guy is pretty much very all he does is just the middleman, right? The middleman that connects this guy to this guy. So yeah, this one towards the right is the guy that does the heavy lifting, and this guy does like the collection from the web and stuff. So yeah, I would like to walk us through uh, um, like some of the codes, right, that run on them, right? So okay. Okay, so we've gone through this one. This is the one that's right. This is the one that that the code that lives inside of the ESP8266 chip, the one that collects RESTful requests, right, and then sends data via serial, right, to the other Atmega chip. So we go into the Atmega the event one, right? So this is the guy that collects this event 1 1. This one is the one that collects the data directly, right, from the ESP86s. Now, what you notice is that, right, what you notice is it is doing some URL decoding and trying to know if it's a get, if it's a post, it's a put, blah blah blah. But the concept is that, right, all this one does is that it just reads the URL that it sends, that the ESP fetches, right? He reads it and and then decides what to do with it, right? It decides what to do with it, and then and then send the resulting command to the later inventor, the later mega chip. So yeah, so pretty much that's what happens here. And then this one, what this one does is the heavy lifting. This is the guy that actually collects all the details from the sensor, that actually writes into the analog pin, that writes into the digital pin and stuff. So one of the things you will notice is that, for example, I'm using a lot of things that I wrote in the library. So I'm not really using the digital write and digital write and digital read. I'm not using. I intentionally did not use them, right? And I think the reason why I did that was because I wanted to. I wanted to understand how a lot of things pretty much flow out, flow into the code base, right? What I mean is this, right? I think I started the project using them at first, but then it didn't really look clean enough for me. So I just said, okay, I'm going to abstract them out into a library, and I'm going to talk to, for example, so this invent digital, right? Um, right. What it does is the guy that actually does the digital write and digital read for an Arduino. So let me come back to this place so that you would see what I'm saying. This is C++ library, yeah, exactly. Yeah. So this is abstracted out. If you say dot write, so what is the actually doing on the background is digital write, right? Albeit right, what you actually then call is invent digital dot write or something like that. So I think one of the things we'll just like do today is writing a library, right? How do we write like a normal library instead of like just using just because it's going to give you this like learning thing, right? So I also abstracted the URL decode into a library, right? Because there's so much happening inside the URL decode, right? Using this like string token and blah 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 and stuff like that, right? But then I didn't want to embed it into the main code, right? I wanted to just make it a library, which obviously is the thing you have to do, right? If you want to write a clean code, clean abstraction and stuff like that. So today I'll just like walk us through like writing like a library and so that you can easily abstract some things out and stuff, right? So yeah, and I think okay, I wrote a library for this sensor as well. Yeah, yeah, what it does is pretty simple, right? Yeah, exactly. So for example, so imagine now writing all this code inside of your code base. Meanwhile, you could just have called dot get obstacle distance, right? That is pretty neat, all right? So yeah, so that's the reason why I actually went that route. I think we'll see a lot of it here. Let me see if I can. Okay, yeah, this is where I'm now bringing them in. I'm bringing them in. If I see, if I can see, SL04. Yeah, cool. Let me see. The obstacle. Okay, let me check it here. Let's see. No, it's not here. All right. I don't think it was used. I was trying to see if it was used, but no, it wasn't used there. Okay, so yeah, but I could have used it, right? All I just have to do is just to call it like the way I called all these other guys, right? I could have just called it easily, and then for example, this DHT sensor, that's the way this library was actually called here, I could just call it. Maybe I'll just show how to do it in the code base pretty much. So um I don't know. Um, is this better? I don't.
Yes.
Okay, this is better, right?
Yeah, but I think it could be better than that, so that we can see.
How about it?
Yeah, yeah, that's perfect.
Okay, cool. So let me just. Um, all right. Let's use this one. Where's this? Okay. Let me save this. Should we create a new tab? Yeah. Okay. All right. Okay. So okay, and then I create a new tab. Called like C as the word setup. All right, cool. So yeah, so like I said, I just want to like walk us through writing like your own library. And if we have worked with HCSR04 before, right? Um it's an ultrasonic sensor, right? And what it does is pretty much gets the distance of an obstacle in front of it, right? It's used to measure distance, right? So it senses the obstacle right in front of it, right, using um, some signals, right, that the sensor basically emits, right, and then use that to calculate the distance. But before all those kind of things, before it can do all those kind of stuff, right, you need to be able to activate the pins in a particular in a particular manner, right? So yeah, there's digital rights. There's this digital right I that is we're going to like send the 5 volts into its trigger pin, right, and also like send a low volt into its trigger pin, right, and this has to be done in a very fast manner, right. It has to be done in a very fast manner so that it can get the right it can just get the right order, right, so that it can get the necessary duration to get the distance, because all these things are pre-calculated pretty much before you get to the obstacle distance, right. So yeah, this is, like I said, it's more of like a C++ kind of thing, right, than it's in C. So in C, right, I would not necessarily, of course I can also abstract things out in C, but then like as in it wouldn't be in this manner of say, okay, class HCR04, right. It would just be okay, my if and def, and then I'll just write my function blandly out inside, right. Instead of having this, I'm just gonna have like in get o- obstacle distance, right, and then that will be all, right. That this is like a standard C, and then in my C plus and in my dot C, right. Let me create a new one. Let's say create HCSR04.C, right. And in my dot C, I'll do my include, HCSR04.H, right. And then I'll just do int get obstacle distance, right? Like this. Yeah, this is it, right? And then I'll write my code here. So maybe you just got a voice, since I'm not passing anything, but yeah. So the difference actually is that C++ has this like an OOP side of it, right? But C doesn't, and C is just like just straight up, right? And then you probably might ask, okay, because so for example, if I'm going to use this, if I'm going to use this code, for example, on a normal Arduino, right? What happens is that I will just I'm going to do something like HCSR04, right? Yeah, cool. And then I'll call it AC. I'll do something like ACSR04, and then I'll name some pins. Maybe I can say pin 12 and 13, right? Pin 12 and 13 being that, okay, I forgot to include it. So include AC AC underscore SR04.h, pretty much. Right. So I've sorry, 04. Okay. So the reason why I'm doing this is because, yeah, in the specification of the library, it requires that I have to call one my trigger pin and the other one my echo pin, right? So just like trigger and echo, trigger means like I'm going to send something to it, and echo means I'm going to be listening back on what the pin is saying, right? So let me just say um, 12 is trigger pin and 13 is the echo pin, right? Echo pin, right? So right here, I'm going to so in what they call it in C++, right? There's this concept of a constructor and a concept of a destructor, right? Now this is the constructor here, right? This is the constructor, right? Why this is like the destructor, pretty much, right? It's always non needed, but it's standard practice to usually have it, right? At least for the Arduino set of libraries, right? So the destructor is like you actually want to get rid of some things. Constructor means you actually bring building things up, right? Right. So yeah. So now if I'm going to use if I'm going to in my main, okay, let me bring I can as well put this here, right? I can as well put this here. It's still the same thing. It's not going to have any defect at all, right? Because what this is doing is that it's basically energizing my constructor, right? This that's what this is doing here. And inside of my loop, I can then say I want to have um, my HC, although this one is not going to exist anymore at this point, right? But reason why I put it outside in the first place. But ideally, right, the reason why putting it outside might be of importance is because if I want to also use it in this loop, right? If, for example, I'm not going to use it in this loop, right? If I'm not going to be using it inside of the loop, I can just easily do this, right? The, right, pretty much. And then I can just do the normal serial dot print something, right? And then this immediately the program starts inside the night controller. What happens is that this is what it actually does first, right? This is what it does first. It does this serial prints and then it shows it, and that's all. But if I'm going to be needing it inside of the loop, I need to make this some sort of, I need to put it in a global scope, right? So that this function can also like, uh, can also know about the that particular memory object, right? So let me just take it back there, and then I'll just put it here, and then loop. So essentially, what will happen here is that this guy is going to, let's say, we'll put a delay of 1,000 seconds, for example, right? So at every 1,000 seconds, the guy basically gets prints on the screen the distance, right, based on the obstacle that's in front of it, right, at every 1 second. That is a delay of 1 second. So yeah, so this is how you're going to use it. Now let's look at how writing the code basically works for C and then for C++. So for C++, right, we've already agreed that this is for the C++, right? it has this, it's trying to put some things into the public scope and stuff like that. It has an OOP side of it. That's pretty much the difference between C plus plus and C, right? And then but then for C, it's just straightforward. You just get to uh, uh, and just right. So let's go with for the C programming, right? Let's check this out. It is very straightforward. Just have it like obstacle distance, right? Right. Yeah. So this is for C, right? And then yeah, so let's look at that first, and then you come to this place, and then you just have it right here. So the logic, right, that does the set pin high and set pin low will now basically happen in this function, right? Right. So the thing is, the reason why using like a C, right? The reason why using C++ is good for the libraries is because you are going to have access to the already written libraries by Arduino, right? So if you're using C, right, you won't have access to this digital, right, because right, it's not written in a way to support what you're going to write in, right? So reason why to stick with C++. But albeit if you want to say you just want to like stick and go ahead with C, right? You can just do like some sort of some sort of your own form of digital right, which is to pretty much like set a particular pin to like one, right? So let's say we have something like this, right? Yeah, I would rather do this. Okay, let's put it like this. Yeah. So um yeah, so although this time right is not going to work for C, right, because it doesn't really have the things for C++. But anyways, let's just go ahead with the C++ folks, right? Because for the C, you can't run a direct C code onto the Arduino through the Arduino system, although you can do it right, just generating your X and your binary straight up, and then burning it straight into the microcontroller, right? But then because Arduino is kind of like, it's a really high level of abstraction, right? They already made it everything, in a particular manner, right? So we just have to like work with what the IDE Arduino IDE has provided, right? So um, yeah, so yeah, so like I was explaining before, there's the concept of the constructor in C++. Let's just go back to using C++. All right, so there's a concept of destructor and constructor, and this constructor ought to be called at the beginning of the code, right? So that you're going to have access to the library itself, right? Now, at the beginning, it's pretty much the first thing that happens. So when you call this constructor, there are some initialization things that happen. So this is more like the initialization stage, right, where it basically sets the, okay, for example, what this pin mode does, right, is that it sets the pin as an output, right, and then this one sets the pin as an input. The reason for this is these are just like guards, right, so that at the time of writing the code, you are not going to try to make it an input, right? It's more like you are protecting that particular pin, right? So it's more like saying that it's more like calling something a const and then trying to rewrite something into it, right? No, that's not possible because you have initially called it a constant, right? So those are like guards, right? Same thing with this pin mode, right? It pretty much just says, okay, fine, since you define this guy as an output, and then nobody's going to be able to, write and input back into it. And define this guy as an input, meaning that nobody's going to be able to read data, uh, uh, just read data from it, right? In that sense. So because it only gets data input into itself. So and this is a function, right? If I'm going to write any other function, it has to also be in this format, whereby, say, maybe if I want to like do maybe something as silly as maybe um get lead name or something like that, right? Right. So yeah, very easy, and then you just return something. Uh, yeah, it's pretty much like this, right? So yeah, so this is basically how you're going to, so that it's going to be part of what the it's going to be part of the functions that this HCSR04 is going to bring into the context, right? You have to describe it in this manner, right? So yeah, and then this is like the old the this block of code here, right, is actually the block of code that does the real work to get the distance for you. You understand? And then yeah, you can pretty much just use this, and then it will when you are writing your code, you can just get it like this, and then the data is going to be gotten straight up. And yeah, that's pretty much it actually. The reason why this is not here is because we want to have access to it in the loop. So here you can pretty much write things like um, uh, yeah. So you can just write this. This is going to be like your own mini initialization, and in the loop you have like this. So this is how you write library, right? And this is how you consume the library, pretty much, right? It's pretty straightforward, and it's even better to like abstract all your heavy logic into libraries, right? So that you just write it once and then you can use them multiple times, right? So yeah, and then you bring in your H and C++ together, right? Store them into a particular folder and call the folder ACS04, and then you can import them straight up like this. Yeah, so that's pretty much it. Yeah, hello. Can anybody hear me?
Okay.
Yeah, I can
Yeah,
see
thank
here.
you, Victor. So we just asked the audience to drop their questions as comments. So let's see if anything comes up. But yeah, John, do you want to go and ask any questions?
Oh yeah. So from the first part of the lecture of all that you've been saying, Victor, I noticed that we could send commands to pins, different things via HTTP, and
Okay.
I just became curious. Is there a way to secure that route or that communication, so that somebody can just stay from anywhere and start controlling my Arduino by
Yeah.
sending via the URL parameters?
Yeah, so funny enough, right? That was what the question is, the reason why I did this actually way back ago. Yeah, I wanted to be able to like prick people out, right, by trying to control their stuff without them knowing. Do you get so in terms of like security, right, based on what I explained before, right? The this chip right here, right, is the guy that connects to like the network, right? Is the one that connects to the network, and it's the guy that receives all the the restful URLs and stuff like that. It's the one that receives things like this, right, and then sends it over to the other microcontroller, right? Now, so in a world as it is right now, right, if I have access to to a particular IP address, and say, for example, you have this setup and it's your board, right? And if I have access to the IP that this thing is connected to, yes, I would be able to like write something to it, right? But remember, it's not. This is not on a public network. This is a private network, right? So it's basically anybody that's on the same network with it, right? That'll be able to like trigger it. Yeah, but if you, in terms of like security, the security needs to be handled from here, right? Whereby maybe you can do some sort of tokenization process or some auth process, so that just to limit the different kind of requests that this guy is going to send to this microcontroller. Do you understand? So you can obviously do some sort of like, in the software world is like OAuth and stuff, right? You can also have that kind of logic, right, inside of this chip as well, so that, right, not anybody can, before you can send it out to it, you need some sort of auth, or some sort of username and password kind of thing like that. So just things like that, right? Yeah. So do you understand what I'm saying?
Yeah, yeah, yeah.
Yeah. So let me also add that I have seen some implementations in which they use like server certificates. So they use
Yeah.
it like public-private cryptography. It's what you have with SSH. So recall that you can set up some servers on like AWS and some
Yeah.
public cloud, where instead of logging in with a username and password, you have to download a security file,
Yeah.
and it's that file that grants you access to that web server.
Yeah.
So what you just do is you distribute that to the clients that are authorized to do it. It's a bit more advanced, and you can
Yeah.
even you can rotate those keys periodically. So when you connect, if your key is old, it can give you a new key.
Cool. Yeah. Yeah. So, and this is, by the way, the kind of thing that is happening here is not directly on top of, well, it's built, it's built directly on top of TCP, right? But it's not really TCP, right? It's not like socket open, socket close kind of thing, right? It's a very big abstraction, right? That doesn't, that uses socket underline, right? But it's not socket, right? It basically just mimics your normal HTTP server, right? So yeah, yeah. If you were to be like a direct socket communication, right? Yeah, yeah. Using some sort of SSL, right? Would have made sense in this case, right? Yeah.
Okay, great. So I like the sensor that you used, the HCSR04 for the distance measurement or proximity sensor.
Yeah.
Yeah.
Okay. Yeah. There are different variations actually. There's actually even more expensive ones, although with different code name, and they are much more accurate. Yeah, obviously in the sensor world, the costlier it is, the better it will be actually. So yeah,
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 obviously. I mean, I can imagine Americans using this particular sensor during COVID to make a wearable device that will start
yeah,
screaming if people are not
yeah,
the right
exactly,
distance away from him.
exactly,
Yeah.
exactly. Yeah. Yeah, so the concept of this link and stuff was just an idea of trying to combine a software entity, right, into like trying to combine a software entity to the hardware entity, right? So, like, okay, right now, just to create some sort of like a soft interface between the software and the hardware, right? So not necessarily, so building a lot of abstractions on top of the TTL communication, building abstraction on top of like all the I2C and SPI, right? All you just have to do is just to send this, just like communicate via HTTP, and then action is basically done on the hardware, right? But on a much more bigger scope, like much more bigger scope, right? Things are not done like this. Things are this is more like obviously a learning process kind of thing, right? But things are more very things are tightly coupled, right? What I mean by that is that for hardwares actually do the communication themselves. That is this the microcontroller actually. So, for example, in this kind of thing, everything is split into microcontroller. So the first microcontroller gets the data, right, and then sends to this one, and then it's like, oh, all of them are just transferring data to each other and stuff like that. But in the real world, it doesn't really happen like that, right? You Everything is done by one chip, right? Everything is done by one chip, right? One heavy chip, and then it probably might have like a Wi-Fi adapter that it uses to sense connection and for data and for data transfer purposes. But all the heavy lifting and stuff is basically done by itself. So yeah, and then on top of that, you can now build all this TCP communication with directly with the chip, directly with the hardware and stuff like that. I'm not necessarily trying to use like a RESTful kind of thing like this, pretty much. So yeah.
Okay, I think you have space for another question. I would just like to ask something general.
Okay.
As a if I can, okay, you mentioned that Arduino is more built for C++ than C.
Yeah,
So
yeah, the Arduino, the ID, yes.
so your advice for a beginner would be to actually learn C++, not C, or what would
Okay,
you typically
okay,
advise
okay,
if
okay. So,
you
so actually, right, you can code Arduino for like 2 years and not even know that it's like a lot of C plus plus in it, right? Because most of the things they're going to be using, right, are basically like intertwined with the normal C stuff. It's like still functional programming, right? The only difference, the only like spice that C plus plus brings to C is number one, the fact that it has some OOP side to it, and number two is that a lot of libraries have been written for C plus plus, right, rather than C. For example, there are so many libraries in C to do some string stuff, right? So you can do some like to uppercase to lowercase. It's more like things you do in JavaScript, right? Things that trivial, right? So trivial things like to uppercase to lowercase, things that you don't even think about, right? You just call it, right? But then in C, you can't just think about it. You need to write that code that does it, right? So there is no thing that would literally tell you that, oh, okay, just make this into uppercase to lowercase. Now, which is actually the beauty of C, right? Because it actually forces you to do all the so-called simple things. It forces you to actually write the code yourself. So yes, so once so Arduino is the beauty. Arduino is a lot of abstraction on top of real hardware, right? Like it's a lot of abstraction, right? And to come up with the Arduino ID itself, a lot of C code was written and stuff, right? But for friendly so that it can be friendly, right, for people to like quickly grasp and stuff. That's why they added some C++ flavor into it, right, so that you can do a lot of string. For example, you can do some read string, you can do things like to you can do some string splitting. For example, if you want to like split strings into like two based on a particular delimiter, stuff like that. But for C, you can't easily do all these things straightforward like that. But then Arduino just they've written a lot of functions that can help one to do it, right? So I think if you learn the Arduino C code, right, it's not obviously enough, right, for like a normal C. It's not enough actually. There's a difference between the Arduino C and the regular hardware C. Do you get? Yeah, they are actually different. But then learning Arduino is actually obviously it's a good start, right? But going bare bones into C code directly is also like is actually far, yeah, is the thing that one should look out for too as well. Do you get what I'm saying?
Yeah, I do.
So we have an
You
interesting question on the screen, which is how much C++ knowledge should one have prior to starting with, I'm guessing that's with Arduino or embedded systems programming.
How much C++ knowledge should one have? Actually, I think almost zero, really, right? I think you could start with anything as long as you have the board or you have an Android device. You can pretty much, just load things on, right? I think with almost zero knowledge, right, you can start. Honestly, it's very very simple to do.
Yeah, I would say I agree with that response. It's, just jump in and get started, and you'll learn along the way. If you
Especially
see
when you
some sort
have
of syntax that you
board.
don't understand.
Yeah, yeah. Especially when you have dev boards, right? Right. The Arduino, you know, the microbit, you know, like the OSTM boards. When you have all those boards, it kind of like simulates how your computer works and stuff. So you can, turn pins on, turn pins off and stuff. Yeah. So
Okay, great. Thank you very much, Victor and John. It's almost an hour, so I don't see any other questions. So I guess we can call it a day.
yeah, I would also like drop a link to the GitHub and stuff if that helps at all. If in case maybe anybody wants to like go on the challenge to like do their look at how the libraries are written and stuff. Um, yeah. So,
Okay, so um, thank you everyone for making time out to attend this session, and see you next time. Bye bye.